Hello, in this video we are going to sketch the ST, VT and AT graphs for the vertical throw from the moments the ball leaves the hand to the moments when the ball returns to the hand. We are going to neglect air resistance and we are going to take upward to be positive. I would strongly encourage you to take out a piece of paper and try to sketch the answers yourself. So you can pause the video now and join me again when you are ready. Okay, usually I start with the VT graph because it's the most interesting graph. In a vertical throw, the ball slows down on the way up, becomes instantaneously at rest at the peak, and speeds up as it comes down. So for our VT graph, we are going to start off with the maximum positive velocity, and it's going to decrease at a constant rate until it reaches velocity of 0 when it's at the peak. The gradient of this VT graph is of course g is equals to 9.81 meter per second square. Past the peak, the ball is going to speed up at a constant rate of 9.81 meter per second square, and so it's going to be a straight line going into the negative region. Many students will make the mistake of drawing the line this way, but if you do it this way, you indicate a positive velocity, which means an upward velocity, which doesn't make sense, of course. So as the velocity is becoming more and more negative, you're actually speeding up, just that you're speeding up in the negative direction, in the downward direction. If air resistance is negligible, we'll expect the ball to return to our hand at the same speed at which it left our hand. So the final velocity of the ball will be negative u. With this VT graph, it becomes very obvious that the time it takes for the ball to rise up to the peak is the same as the time for the ball to fall from the peak back into the hand. Okay, as we admire our VT graph, remember two features of the VT graph. Firstly, the gradient of the VT graph is acceleration. So the gradient of this VT graph is constant, which makes sense because the ball is free falling at a constant rate of 9.81 meter per second square. The other feature is the area under the VT graph represents displacement. So this positive area here will represent the distance traveled by the ball on the way up, and the negative area here will represent the distance the ball travels on the way down. Notice that these two areas are exactly the same, and this makes sense, of course, because the ball travels the same distance up and down. Alright, once we have gotten the VT graph, the AT and ST graph is just one step away. Remember, the gradient of the VT graph gives the AT graph. Since the gradient is negative and constant, the acceleration time graph is also negative and constant. In fact, the constant value here will be negative 9.81 meter per second square. It makes sense that the acceleration is negative 9.81 and not positive 9.81 because we have chosen upward to be positive. So negative 9.81 will represent downward acceleration of 9.81 meter per second square, which makes sense. Now for the ST graph, it should look something like this. Remember, the gradient of the ST graph gives the VT graph. So notice that in our ST graph, we start off with the maximum positive gradient, and the gradient becomes less and less positive, eventually reaching 0 when it's at the peak. This of course matches with the velocity starting with maximum positive and decreasing until 0 when it's at the peak. Once past the peak, the gradient becomes negative, and it becomes more and more negative until the most negative at the end, right at the end. This of course matches with the velocity becoming negative and becoming more and more negative. Physics-wise, it makes sense too, because on the way up, the ball is slowing down, so the rate at which it rises becomes slower and slower. That's why the ST graph becomes less and less steep. On the way down, the ball speeds up, so the rate at which it drops becomes faster and faster. That's why the ST graph also becomes steeper and steeper. Alright, we are done with the 3 graphs. I hope you found it interesting. Ta-ta!